you so very much for coming. It's great to see a whole bunch of new faces, some old Chrysalis faces, some new faces, and we're here to spread the joy of programming a little bit at a time. So today I'm going to be talking about visualizing open data with Python and D3.js. You probably already know that, but maybe you don't know too much about me. So just a quick self-intro. My name is Ian Cameron. I am from the US. But I have lived 15 years now in Japan. That means I've lived in a lot of places. Well, in my case, anyways. I've lived in Sendai and Fukushima, which actually comes into play here during the talk, and also Tokyo and Osaka. So I've experienced rural and urban Japan. I've also bicycled the Ohenro pilgrimage. I don't know if anybody knows what that is, but this picture is me bicycling around Shikoku. It was about 1,400 kilometers. Trip all around the island, visiting the 88 temples. And that's me at number 88, if you're good at your kanji. So I've got about 10 years experience in IT, but more soft side, more consulting, training, installations, on-site testing, that kind of thing. And I enjoy throwing things. Not today. I know everybody is safe, but I do have some hobbies that involve throwing things. I go bowling a lot. I enjoy darts. And there's a Finnish game that's really cool called Moku. If anybody is curious about that, ask me later on. So, it's all about visualizations today, right? And I find visualizations very inspiring and very powerful. Because words and numbers are processed. Right now you're hearing my words and they're going into your brain and you have to think about what they mean. And finally you have some sort of interpretation. But visualizations are experienced. You see a shape, you see a color, you see a size. It goes in, you have a reaction much more quickly, much more viscerally. So for an example, what is the difference between 227 and 170? What does that mean to you? You could give a percentage maybe if you thought about it for a few seconds. Maybe if I put a size to it. Maybe this square has size 227 and the other one has 170. Or maybe a more human example. Here you go. 227 kilos versus 170 kilos. So there you go. You can see the difference and you can size it up and think about it. So visualizations I found quite interesting. So that's why I thought D3. I had heard about it in being used as a visualization tool. And so I really wanted to get into it. And my first few steps, I made something like this. So it's a little small, but all this is city and population data. It's latitude, longitude, and population of a city expressed as a circle on a map. That's all it is. There's no lines defining continents, but you look at this and you know exactly what it is right away. And you can pick up some really quick and easy, pointers. Let me get my pointer out here. For example, Mexico City, I think, is that area down there. Much larger than I thought it was going to be. And of course, the major population centers of China and India are just blacked out almost entirely. So this sort of got me hooked into the D3 channel for this presentation. And so here's my process. So I knew I wanted to do visualizations, but that's the end project, right? So I had to go and get my data. I had to then get and process that data. And then I had to actually turn it into a visualization. So this is how I'm going to sort of split up my talk today. I've got my data portion, which is a discussion about open data and where you can find data. Then the second part is sort of the Python part. This is where I'm actually getting the data on my machine and processing it in preparation for the visuals, which is the D3 portion. And that'll come up last. And then at the very end, I'll have some of my examples for you. So going into open data. Open data is free, which is sort of why I used it. I don't have money to spend on getting data for my course talk. So open data is data that can be freely used, shared, and built on by anyone, anywhere, for any purpose. So open data is often put out by governments on their statistical websites. It's also put out by some private groups. And I have examples from both of those, actually. But open data can be a bit misleading. It's there, sure, but it still can be hard to find, and it can be not in context. So you might have a little bit of data there, a little bit of data here. What you really want, in the end, right, is everything on the same graph all together, and you just have to throw it into your visualization tool. But often what we get is much less organized. It's not all together. And we'll see that here as I go into examples of how governments put out some open data. So Japanese open data, there's a government website called estat.go.jp. This has been made much better from what I understand in the last couple of years. But it has national and major regional data. It has many different ways to access that data as well. You can access things directly in a database style format, making database queries. You can use API calls to get little bits of data at a time that you want. And there's also some files, there's also some data in file formats that are open for download. And they also have an English page, which is helpful for maybe many of you. So here you go. Here's a quick shot of the English page. You can see they've got a data section. You can search by themes, different organizations, how they put it out. They also have some basic visualizations of their own on their website. I could have just shown that to you, but then I wouldn't have had to do any work. So I actually went out and got data. For my presentation, I actually did not use this website. I went straight to more local data. So I went to Fukushima Prefecture's website. They also have data of all types: population, economic, radiation, because of the disaster that happened there in 2011. But accessibility is more of a problem here. Instead of having things in a nice big database or called from an API, you just have a bunch of files, PDF files, Excel files. Recently, they have some open data files, but those are just Excel files in CSV format. And again, it's hard to get context when this year's data is in this file and another year's data is somewhere else. So here's an example of their website. So this is population data, and as you see, it's just a bunch of links. It's really just a big, long list of links. These are Excel files. These are flat files, your CSV files. And it's not all in one place, and it's all very hard to navigate your way into. So regional data was not so strong. Fukushima Prefecture has its own radiation data, but it's also in PDFs. So I thought I'd take a slightly different route. How many people have heard of Safecast? Is there anybody who knows of Safecast? We have one. All right, thank you very much. Maybe you've been to the Nerd Night talk. So Safecast is an amazing group. It's a volunteer group created after the disaster in Fukushima. Their mission is to keep radiation data and open and honest. So they build and sell devices that you can just put on the outside of your car and collect data. And then they provide a very easy interface to go ahead and put it up online, and you can download directly from this API. You can open up a browser right now and get radiation data out without signing up. Just put in some simple search terms. So a quick summary of my data section. So what I used some city locations, some longitude and latitudes that I found on a website because I wanted to put data on a map of Fukushima, so I needed some locations. I got city populations from that Fukushima website out of some Excel files. And radiation and location data, I knew I could get some JSON data. If you don't know what JSON is, ask me later, from that Safecast API. So I've got my data decided on. Now we need to go ahead and get that data. How many people here know Python? Okay, all right, you probably know more than I do. But, okay, so for you Python nerds out there, I am a newcomer to Python. I jumped straight in with the newest version. I believe it's 3.7.
Well done.
Sorry?
Well done.
Oh, all right. So why Python? It's easy to learn, easy to use, and it has loads of libraries. I did not exercise Python to its full extent, but I did use it. So just a quick introduction. It is easy to learn. Syntax is easy to learn. There's simple syntax, fewer brackets and parentheses than other languages, which can get confusing. And also it's white space delineated. Now, maybe you don't know what that means exactly, but it means that the program's shape influences how it functions. So usually good programmers will indent things. You see things are slowly moving into the right in my code here. Python actually enforces this. If you do not structure your program visually in a way that the computer can understand, it will not work. So in that sense, the structure of the program and the visual experience of coding is a lot more direct and easy to follow. Python is also easy to use. Here you see a 3-year-old learning Python. I'm sure they're just watching YouTube or something, unfortunately. So there are great tools in Python. Pip is something that you can use to download all of your libraries, which I will talk about in a few seconds. There's also a virtual environment. So if you're doing a lot of different projects and you use a lot of different tools, again, this is a bit complicated to really describe in detail, but there's this awesome tool that keeps your projects separate from each other so there aren't any conflicts. There are also very straightforward ways to read and write files, which are not a given in other languages like JavaScript. And there are built-in data types for analysis. So it's this easy to learn and easy to use sort of aspects of Python that made it very popular. And also it's open source. So in a world where perhaps visualization tools or mathematical analysis tools are very expensive, this is a free platform to build your own thing on top of. And people did exactly that. They built all of these, also open source, libraries. So I brought these two out first. Requests and Beautiful Soup are two very simple Python libraries to get data from the internet and then to parse it and understand what's in it. But, people who know a lot more about math than me, made all of these amazing things that you can use to do more complicated data analysis, do visualization straight from your data, and also do machine learning. Later on, we'll have some talks about ML5, which is something based on TensorFlow, which sort of started off in the Python world. But again, lots of modern technologies are being built on and around the Python language. So here we go. So here's what I used. Again, just a quick summary. If you want to get into more details about what I did and exactly how I did it, I'll be happy to talk with you later. But I used requests to get data off the internet, whether that was HTML or an Excel file, or even calling things from the Safecast API. I used Beautiful Soup to sort of sort out the longitudes and latitudes of my city data. And then I used a couple of libraries for getting things out of Excel, and also dealing with some of the eccentricities of Japanese text. If many of you probably know, Japan has full width numbers and half width numbers, and they don't play too well together, especially if you want to treat them as numbers. So that's where I pulled that in on. Okay, so I've got my data. I know how I'm going to get it, and actually I've already gotten it in this story. So here we go. Here is D3.js, which is the library for JavaScript that I used to actually create some of these neat visualizations about Fukushima data. So a quick introduction to D3.js, or D3 I'll call it. It can help make your data come alive in a web page. Graphs, charts, maps, dynamic and interactive visualizations as well. This picture over here on the right is actually just a bunch of different sample visualizations that are on their main website, which is d3js.org. But all amazing. You can just click through. You can see how they created them as well. It's a very informational website. And amazing, really, what you can create with a simple basis of data and some JavaScript code. So what does D3 run on? It runs on the basics of the internet. So of course you've got your HTML, CSS, and JavaScript. And sorry to anybody who's not really familiar with all of these terms. If you want to know more, come up to me later. But what it really leverages in a big way is this thing called scalable vector graphics. So scalable vector graphics are rendered by the browser. So you tell the browser, I want a circle, I want it here, and I want it this radius. Now the browser can take that information and render it in a very clean way. If you give a browser a JPEG image or just normal standard image data, as you make that image bigger and bigger, it'll get more and more grainy and look uglier and uglier. Whereas these scalable vector graphics stay clear the whole way. And if I have time, I'll be able to show you a little bit of that in my demonstration later on. So what is D3 actually doing? So there's a lot going on this slide. But basically, you've got your data over here in a big table maybe. And D3 is the go-between, between that data and these elements that I was just talking about. So your SVG is a big list of circles. But where do those circles go? That's where D3 comes in. D3 will map each of your data points to a circle. And it will use scales to say, take my latitude and longitude data and tell the browser exactly where on the screen that circle should be for, say, Fukushima City or Iwate City. Not Iwate City, Iwaki City. Sorry about that. And it also uses CSS. So all this then comes together in your browser to make a magical thing that looks very pretty. And hopefully mine will perform well. So here it is, the moment you've all been waiting for. I hope. Some quick visualizations. All right, so let me zoom in a little bit on this. All right, so what we're looking at is population and population change Fukushima 1999 to 2018. So again, I took off all of those population files, one per year at least was what I sort of pared it down to. And it's a little bit faint, but you can see here, I've got circles over each of the major cities and villages in Fukushima. The size of the circle is, of course, in proportion, or sorry, the area of the circle is in proportion to the population. Just for reference, you have 100,000 population is about this size. And here we have change per year. So since this is the first year, you're not seeing any change yet. But as I move my pointer here over the bottom, this year section, I will actually go through time and show you different years of the Fukushima population growth and how that happened. So again, you can, just building this, you can see new things that you maybe wouldn't have seen before and learn things about your data. So this is more about the power of visualizations than maybe the very detailed stuff about how to write D3. But as you can see, Fukushima and Koriyama, sort of in the core area of Fukushima, grew this year. But as you go through the years, you actually find that Fukushima is like a lot of other places in rural Japan that is generally suffering from a shrinking population. Whether it's, the elderly who are slowly, growing fewer and fewer and not being replaced by younger people. I tried to say that as nice as possible. Or if it's just like people moving out of the countryside and into the city. And you also see some very interesting things here. In 2005, I've got this very green circle right here. That is Aizawa Wakamatsu City. Why is all of a sudden, why is Wakamatsu getting very big? And if you go back a year, you'll notice that there's a circle right here, actually. And if you go to the next year, that circle disappears. So you can also see things like Gappei, which is the how Japanese villages are slowly absorbed into the larger municipalities. So you can see little blips of bright green here and there, where smaller circles are disappearing and that population is moving to the larger city and making it look like that city grew, whereas actually it probably shrunk overall. So I'm just going to zip through a little bit more. 2007, 2008, for those who can't see. For those who can see on the bottom, there's a little red line going through my date. That is the year that the disaster happened in Fukushima. So after this, especially if you go one more year, you will see a lot of red. A lot of people moved out of Fukushima, out of these different areas. And as you continue on, again, generally the trend never gets to sort of where you were seeing some green. It's just, this is I can't quite explain this one. This might have been another year where a lot of cities also grew bigger. But also in this year, you'll notice on the right side of the chart, all of these circles disappeared. These are the circles immediately around the Fukushima reactor. And actually in the data that Fukushima publishes, they showed numbers for a while. In the last few years have just been hyphens. So I don't know if they're not counting or if it's just fully evacuated and they just stopped trying to call that the population of that town. But it's now being communicated to the public as zero population. So there you go. Here's a quick and simple, the data really isn't that complex, but it's interesting when you get it up onto a screen and see the different trends that you can pick out. So I'm going to go ahead and go to my next visualization. This is very similar. So here you see, this is SafeCast data. So I did a scan across Fukushima. My scanning wasn't very great because there was just a lot of data and it would have taken me a long time to get all of it. So it's a little sparse, but here you can see, this is the area here on the east coast of Fukushima where the nuclear reactor was. And you see that the radioactivity largely went up into the northwest towards Fukushima City, which you see just to the left of this giant purple peak here. And like the other one, I also animated this one, so you can go through And you see 2012. Again, data is looking a little sparse. I will show you in a moment something with a lot more data on it. But here you go. You can sort of see that the general levels are dropping as you go through time, 2016, 2017, and 2018. And also maybe as time goes by, Safecast data isn't being measured quite so much as before. So here you go. If anybody's really curious, this is counts per minute data from Safecast. But just another real great way to show, and in this circumstance, it's a 2D data. I'm taking latitude and longitude, but by squishing my image down a little bit and making the bars show up just in the right place, I could make it basically a 3D image. So again, like I said, this data is a little spaced out. I do have much more defined data for this year of 2015 though. So let's go to that. And there you go. If you make a finer scan, you can get a lot more data and see a lot more detail here and there. So, but again, the general theme is the same. You see a huge spike around the reactors and up towards the direction of Fukushima City, whereas Iwaki is not that badly affected in the southeast, and some sort of lingering along the main corridors of Fukushima Prefecture. So that's my demos. Let's just go back for a quick wrap-up. Advice and conclusion. I don't know if I can give much advice. It sounds like many of you are very good, hopefully, with Python already. Give me tips, actually. Please talk to me. Python, if you're starting out, learn pip, of course, because that's how you need to get all these great tools like Beautiful Soup and requests. And, if you want to go crazy with numbers, go with pandas or NumPy. Also, general Python and library tutorials. I referenced one in my talk when I created that world map, but if you're curious, I can share more with you. And figuring out the soup can be hard, but stick to it. For those of you who have not scraped the web, who have not tried to get data out of websites, it can be a bit difficult, but it's just a game of just trying, sticking to it, and finding those little keys that can help you get that data out. As far as D3.js is concerned, Curran Kelleher, that's the world map guy. His tutorial was really good for getting started on D3.js if you've got a little bit of JavaScript background. And learn what's called the general update pattern. So especially if you're making your D3 visualizations interactive, this is the thing that's going to refresh all of your data. So when data disappears, it removes things from your picture, and as new elements come on, it paints them fresh for you. And also be careful of versions. I found a lot of very interesting examples of D3 on the internet, but when I tried to put them in my environment, they did not work because that just wasn't what it was called anymore. It was a D3 version 2 example, and I was on version 3. So again, very sort of beginner kind of mistakes that I made, but important to be conscious of as you go forward. So that's all for me. Thank you very much for your attention, and enjoy the rest of Big Miniconf. Thank you.